good evening, and thank you for drifting in with us tonight. Tonight, we're stepping back, far back into the deep contemplation of interstellar space, a world where our sun is merely one station on an endless cosmic railway line. Let us begin this long, quiet journey with a simple thought that reframes your entire cosmic address. Imagine, just for a moment, that the solar system, the sun, the planets, the asteroids, the familiar neighborhood you've always called home, is not a closed system. Imagine it as a grand, slow-moving railway station, and once every generation or two, a truly unique, interstellar express train slips quietly through our orbit, traveling on tracks laid across the deep, dark galactic void. We are speaking of an object so rare, so foreign, that its chemical composition is literally a secret held by another star. And right now, one is here. Its formal name, which carries the whispered weight of scientific discovery, is 3I Atlas. The I stands for interstellar, the quiet understanding that this visitor was born not in the swirling, primordial gas cloud that birthed our sun, but elsewhere, a star system perhaps light years away, across the immense, lonely gulf of space. The Atlas refers to the Asteroid Terrestrial Impact Last Alert System, the robotic survey telescope in Hawaii that first flagged this anomaly. In its early images, taken on the 7th of January, in the year 2020, 3I Atlas appeared as nothing more than a faint, tiny smear of light, yet its trajectory was immediate and conclusive. It was moving too fast, following a hyperbolic path that proved it was not gravitationally bound to our Sunday. It was only passing through, an astronomical ghost passing through a brick wall. Here is the subtle paradox, the quiet mystery that keeps astronomers up at night. Interstellar objects, by their very definition, are supposed to be random. They should tumble in from every conceivable angle, the gravitational equivalent of cosmic flotsam and jetsam, churned by millennia of galactic tides. But 3I Atlas is the second such object we've definitively identified, following the famous Oumuamua in 2017. Finding one was a statistical triumph. Finding two, so soon after the first, forces a stunning question. Are these objects rarer than we thought? Or are they so common that the solar system is perpetually bathed in a silent, invisible drizzle of matter from other stars? And if they are common, why are our models so consistently incorrect about the abundance of these travelers? This leads us to the central question we will explore tonight. What if 3I Atlas is more than just a piece of rock or ice ejected from a distant star's stellar nursery? What if its composition, its strange speed, its subtle and difficult to measure non-gravitational acceleration is a fingerprint, a clue to a cosmic architecture we have yet to fully appreciate? What if we are looking at the residue of a cosmic cataclysm far grander than anything we can observe today? This is the ancient motif of the stranger from the sea, the sudden appearance of the foreign, the unknown, carrying knowledge and materials not of our world. The arrival of 3I Atlas echoes the tales of the star people from the high deserts of Chile, or the legends of sky stones that fell to earth, forever changing the composition of our soil. It is a modern myth of the cosmos. Settle back now and feel the gentle, rhythmic turning of the earth as it carries you through the cosmos. Think of that faint, tiny speck of light, an object that has traveled across unimaginable distances, now gliding silently past your home. Its indifference to us is absolute, yet its presence is a profound reminder of the vast, vibrant interconnectedness of the Milky Way galaxy. We are not isolated, but rather a temporary way station on a grand, silent thoroughfare. The night has only just begun, and the universe is vast. Just before you drift into the deep contemplation of interstellar space, please leave a comment telling me what time it is and where you are listening from tonight. We start this long documentary with a quiet acknowledgement. 3. Atlas is here. Its presence recalibrates our cosmic census. The simple fact of its interstellar origin is only the first layer of the mystery, a curtain drawn back just enough to reveal a sliver of the spectacular and strangely busy galactic environment we call home. We must now turn our attention to the cold, hard evidence itself and see how deeply the mystery truly runs. The quiet arrival of 3I Atlas forces an inevitable act of historical re-examination. If the statistical abundance of interstellar objects is indeed 10,000 times higher than we once believed, then it stands to reason that previous interstellar visitors must have slipped through our solar system undetected, or perhaps worse, they were detected but simply misclassified as highly eccentric, local comets. We are entering the realm of astronomical archival work, searching for echoes from the past in the dusty records of old observatories. Imagine the painstaking work of an astronomer, perhaps a quiet researcher at the Minor Planet Center in Cambridge, Massachusetts, poring over the faded photographs and handwritten logbooks from the late 1940s or the early 1970s. They are looking for subtle, systematic errors in the orbital calculations of historical comets, the subtle deviation from the expected elliptical path that, in retrospect, would have been the telltale sign of a hyperbolic trajectory. The crucial piece of evidence is the hyperbolic excess velocity. This is the final, measurable speed an object has as it recedes from the Sun, a speed that is mathematically impossible if the object is gravitationally bound. In the early days of comet tracking, before the advent of precise, computerized orbital mechanics, the subtle, often tiny difference between a highly eccentric ellipse, a local comet, and a true hyperbola, an interstellar object, was often lost in the noise of observation. It was a difference of mere meters per second, a rounding error in the vastness of space. One notable candidate from the past, often cited in this search, is the infamous comet Lexell from the year 1770. While its path was never definitively proven to be hyperbolic, its extremely close approach to the Earth and its subsequent dramatic change in orbit after interacting with Jupiter suggests a dynamically unusual past. Another, more modern example is Great Comet of 1882, whose origins were notoriously difficult to trace due to its close grazing pass of the Sunday. Could these ancient, enigmatic visitors have been interstellar travelers that we simply lacked the mathematical tools and observational precision to identify? The search for these unidentified hyperbolas carries a profound mythic link to the ancient idea of lost scrolls or forgotten knowledge. The answers to the comet's abundance may have been present in our archives for decades, but our collective scientific mindset, the deep-seated belief that the solar system was an isolated entity, prevented us from asking the correct question. The knowledge was there, waiting in the dust of old calculations, but the philosophical context was missing. Consider the role of the computerized surveys in the modern era. The fact that 3I Atlas was found by the Atlas system, an automated, robotic network, underscores a truth about modern science. Our best tools for finding the unexpected are the ones that relentlessly apply a consistent, mathematical filter to the entire sky, free from the human biases of what should be there. The computers simply calculate the trajectory and flag the hyperbola without prejudice. This search for echoes from the past also informs our understanding of the three anomalies. If we find a historical comet with a subtle, misclassified hyperbolic path, and if we can confirm that its light signature, as recorded in old telescopic plates, was also subdued or volatile poor, then we have not only found an interstellar object, but confirmed that the chemical recipe of the alien kitchen has been circulating for centuries. It strengthens the entire case, moving it from a statistical anomaly to a confirmed, ongoing galactic process. The subtle humor in this archival hunt is that the most cutting-edge discovery of the 21st century, the realization of abundant interstellar traffic, is now forcing scientists to become 19th century history. Detectives, magnifying dusty photographic plates and rerunning calculations that were once considered settled. Science constantly cannibalizes its own past in the search for the new. The viewer queue invites a moment of quiet historical reflection. Imagine the quiet astronomer in 1882, staring at the streak of the great comet, writing down its position with painstaking care. They did not have the word interstellar for an object within their grasp. Yet the data was telling the story. Close your eyes and feel the connection across the centuries. The human effort to map the sky, which ultimately led to the quiet confirmation of this galactic traffic. The search for unidentified hyperbolas provides a crucial piece of human reflection. It is a testament to our ongoing scientific evolution. Every observation is a product of its time, constrained by the prevailing wisdom and technology. The passage of 3I Atlas is the ultimate, humbling reminder that the cosmos is always ahead of our current understanding, and the most important truths are often hidden in the most mundane, overlooked data points. The true significance of 3I Atlas will ultimately be measured not by its own speed, but by how successfully it has corrected our historical census. If this comet leads us to identify a dozen more travelers in the archives, then it is not merely a single object, but the key that unlocked a vast, previously unseen population. The echoes from the past are growing clearer, forcing us to integrate the vast, external reality of the galaxy into our internal, solar system-centric view. The cosmic perspective is now pulling us even further out, to the very edges of galactic structure. Having established the violent birth of 3I Atlas and the chemical secrets locked in its icy heart, we now zoom out further, embracing the cosmic perspective to understand the architecture of its journey. We are asking a fundamental question: what forces, besides the initial gravitational slingshot, guide these nomads through the immense galactic void? The answer lies in the subtle, pervasive influence of galactic tides and the motion of massive, invisible structures. Imagine the Milky Way galaxy itself, not as a flat, static disk, but as a vast, swirling oceanic current, 100,000 light-years across. Our solar system is just one tiny molecule in this immense flow, orbiting the central black hole at a speed of approximately 220 kilometers per second. Everything in the galaxy is subject to this constant, subtle, yet overwhelmingly powerful gravitational pull from every other star, every dust cloud, and every dark, mysterious element of the galactic halo. These are the galactic tides, and they are the unseen navigators of interstellar objects. A fragment like 3I Atlas, once ejected from its home star, is no longer subject to the strong, local gravity of that star. Instead, it drifts into a regime where the collective gravity of the entire galaxy becomes its master. The pull is subtle, acting over millions of years, slowly curving the hyperbolic trajectory of the object until its path across the void is a wide, gentle arc that traces the spiral arms of the galaxy. This is why these objects arrive at our solar system from seemingly random directions. Their path is not a straight line, but a complex, braided track dictated by the shifting gravitational landscape of the Milky Way. But the architects of this journey are not merely the visible stars. They are also the massive, unseen concentrations of material we have only inferred through their gravitational influence. We are speaking, of course, of dark matter. Though we cannot see it, this mysterious substance makes up approximately 85% of the total mass of the universe and forms a vast, diffuse halo that envelops the entire Milky Way. Dark matter is the invisible scaffolding of the galaxy, and its gravity is the silent hand that guides the largest motions. The trajectory of an interstellar object, like 3I Atlas, is therefore a map of the dark matter distribution in our galactic neighborhood. As it passed through the halo, its speed and direction were subtly influenced by the denser pockets of this invisible material. While current instruments are not sensitive enough to precisely calculate a dark matter density from the single track of a comet, the sheer fact of its arrival and the arrival of Oumuamua provides a quiet, statistical confirmation that the gravitational environment in our solar system's region of the galaxy is a complex, active space. These interstellar nomads are essentially tiny, very fast gravitational probes, silently confirming the structure of the cosmos itself. Let us consider the subtle humor in this arrangement. For centuries, philosophers and early astronomers assumed that the space between the stars was simply the void, the passive blackness where nothing happened. They assumed that once an object left its star system, it was lost to an infinite, straight-line path. The reality, confirmed by the path of 3I Atlas, is far more dynamic. The galaxy is less of a void and more of a subtle, gravitational whirlpool, where every object is influenced by every other. Even in the deepest, darkest space, there is no such thing as truly straight-line motion. The cosmos is simply too crowded for perfect solitude. This understanding also allows us to appreciate the concept of the star nursery, from which 3I Atlas originated. Most stars are born not in isolation, but in vast, crowded stellar clusters or associations, sometimes containing thousands of young stars. In these chaotic, early environments, the gravitational interactions are intense, and the ejection of planetesimals is a common, almost continuous event. The fact that we are seeing 3I Atlas arrive now means that its ejection event occurred at a specific time and location along its arc, sending it in the direction of our Sunday. It implies a moment of spectacular violence, perhaps 100 million years ago, when its home cluster was at its most dynamically unstable. Imagine the young, brilliant star of its birth, perhaps a chaotic, rapidly rotating B-type star that burned its fuel quickly. 3I Atlas would have been violently cast out, a billion years too late for its own home world, and it has been drifting ever since. This deepens the mythic link to the idea of cosmic fate or predestination. Its journey was set in motion by a force so powerful that it dictated an arrival into our solar system, on our timeline, entirely independent of the 400-year-old telescopic technology we used to find it. We must now turn our attention to a very specific time marker and its subtle psychological effect, the 4th of December, 2021. This was the day of 3I Atlas's perihelion, its closest approach to the Sun, slightly outside the orbit of the planet Saturn. It was at this point that the comet's speed was at its maximum, and the subtle outgassing of its icy surface should have been at its peak. The observation period around this time was a moment of profound, quiet tension in the astronomical community, a brief window to capture the deepest chemical secrets of the traveler. Every major telescope array, from the European Southern Observatory in Chile to the Subaru telescope in Hawaii, was quietly focused on this fast-moving speck. The results from that perihelion period, while scientifically invaluable, confirmed the comet's strangely subdued nature. The activity was less dramatic than expected for an object of its scale, a quiet confirmation of its armored, dense core. It moved with the silent confidence of a true nomad, barely acknowledging the gravitational majesty of the sun before continuing its long, quiet, and now receding journey. Consider the three anomalies once more. The high abundance suggests an almost continuous flow of galactic debris. The subdued outgassing suggests a hardy, unique composition forged in a distant, perhaps more violent, system, and the hyperbolic velocity confirms its status as a permanent, untethered wanderer. Together, they force us to abandon the cozy idea of a closed solar system. We are not a fortress. We are a harbor on the galactic shore, and the tide is always bringing in new material. The cosmic perspective asks us to understand that our solar system is a brief, sunlit moment in the life of 3I Atlas. It passed by, gathered a little solar energy, and is now leaving, utterly uninterested in the dramas of Earth. The great galactic tides that brought it here are already pulling it toward its next destination, a journey into the dark that will continue for millions of years. This traveler is a quiet reminder that the most profound motion in the universe is not the simple, local orbit, but the great, slow, endless drift of the galaxy itself. The human reflection on this reality is the next, most subtle phase of our journey. We now turn inward to understand what the existence of this traveler says about us. Having established the statistical abundance of interstellar objects, we now return to the micro scale, focusing on the subtle, silent drama playing out on the surface of 3I Atlas as it recedes from the Sunday. We are undertaking a profound piece of chemical archaeology, attempting to decode the recipe of the alien kitchen, the unique blend of materials that makes this traveler chemically distinct from our own solar system's comets. Imagine the nucleus of 3I Atlas, that enormous, 137-kilometer wide heart, as a vast, deep-frozen geological time capsule. The surface, warmed by the distant, diminishing light of the sun, is undergoing a process called thermal decomposition, where the long frozen ices of various compounds are turning directly into gas. This gas forms a vast, diffuse atmosphere around the nucleus, called the coma, and it is this gas that provides our only chemical clues. When scientists use the powerful spectrographs on telescopes like the Keck Observatory in Hawaii, they are essentially analyzing the smell of the comet, looking for the telltale spectral lines of different compounds. The expected signatures for a comet born in our own Oort cloud would be dominated by water ice and carbon monoxide, with a predictable ratio of other ices like carbon dioxide and methane. This is the standard, local recipe. However, the analysis of 3I Atlas's coma, particularly the data gathered in the weeks following its perihelion on the 4th of December, 2021, revealed a significant deviation. While the comet did produce the expected water, the abundance of other volatiles, particularly nitrogen-bearing molecules like cyanogen, showed an unusual ratio compared to solar system comets. More importantly, The depletion of certain hypervolatiles, the materials that turn into gas most easily, was stark. It was chemically less volatile than its local counterparts. This less volatile signature is the crucial piece of the alien kitchen puzzle. It implies one of two possibilities, both of which radically reshape our understanding of planet formation. Possibility 1. 3I Atlas was formed in a region of its home star system that was significantly warmer than the birthplace of our own comets. The higher temperature would have effectively baked out the most volatile ices, the easy-to-gasify components, leaving behind a core that was intrinsically less fluffy and more dense. This object would be chemically and physically armored, explaining its delayed, subdued outgassing the second anomaly. This suggests a home system where the frost line was much closer to the star, or where the process of planetesimal accretion took place much faster and hotter. Possibility 2. The star system of its birth was dramatically different in its elemental abundance. If the cloud that formed its star and planets was metal poor, or if it had been significantly enhanced by a different type of nearby supernova explosion, the building blocks of its ice would be fundamentally different. For instance, a higher proportion of refractory materials, substances that resist heat, would be present, giving the core its unusual density and resilience. This chemical deviation is the comet's alien accent, a subtle difference in its spectrum that says, unequivocally, I was not made here. The mythic link here is the ancient idea of the philosopher's stone, or the elixir of life. For centuries, alchemists searched for a single substance that contained the key to creation or transmutation. 3I Atlas, in a scientific sense, is a piece of cosmic philosophy, a sample of material formed under dramatically different initial conditions. It is the real-world equivalent of the philosopher's stone, a single sample that contains the key to understanding an entirely different, remote, and long-dead stellar system. Imagine the quiet intensity of the scientific team, perhaps led by an investigator at the University of California, Los Angeles, spending endless nights comparing the chemical inventory of this single traveler to the dozens of comets catalogued in our own solar system. This is a profound moment of cross-system comparison. We are finally able to compare our local ingredients to those from a distant star, confirming that while the laws of physics are universal, the resulting chemical recipes are diverse and unique. The three anomalies are all chemically linked. The high abundance of these objects suggests a vast number of chemical recipes are circulating. The unusual chemical composition confirms the diversity of the recipes, and the delayed outgassing is the physical manifestation of the hardened, less volatile ingredients used in the alien kitchen. This is a quiet, humbling moment of human reflection. For all our advanced technology, all our astronomical power, the most profound discovery is simply a chemical difference in a faint streak of light. It tells us that our own solar system, with its familiar balance of ice and rock, is only one possible outcome among an infinite number of cosmic possibilities. The vastness of the galaxy is not just spatial, it is also a chemical vastness, a spectrum of elemental blends we have only just begun to sample. The viewer Q invites you to contemplate this chemical difference. Close your eyes and imagine the smell of the 3I Atlas coma, a faint, ancient scent of cyanogen and water ice mixed with the subtle, unidentifiable scent of another star system. It is the most distant perfume you will ever encounter. The decoding of the alien chemical recipe is only the beginning. The next logical step in our journey is to look for the historical precedents of this unique traveler within our own local inventory. Did the galaxy send us other interstellar objects in the past that we simply failed to identify? The echoes from the past are subtly demanding our attention. To understand the alien, we must first look into our own quiet archives. Having navigated the philosophical implications of the interstellar traveler, we must now retreat from the grandeur of reflection and dive into the quiet, complex world of statistics and probability. The true revelation of 3I Atlas lies not only in its composition, but in the simple fact that we found it at all. This is the moment where the great silence begins to speak in terms of vast, quiet numbers, forcing a radical re-evaluation of the density of interstellar space. Imagine the entire volume of space that our solar system currently occupies, a vast, three-dimensional sphere stretching out to the Oort cloud, perhaps 50,000 astronomical units from the Sunday. This volume is essentially the cosmic net that we are casting. Until the discovery of Oumuamua in 2017, the most widely accepted scientific models, based on theories of planet formation and ejection rates from early star clusters, predicted an incredibly low density of interstellar objects passing through this net. The general consensus was that, given the limited power and scope of our existing telescope surveys, finding one would be a statistical fluke, a once-in-a-century event. The models predicted that, for every 100,000 years of observational time, our current telescopes might be lucky enough to detect a single large interstellar object. This assumption was based on the idea that the process of planetary ejection was a relatively inefficient one, and that the vastness of space would have thinned out the population of travelers to an extreme degree. But the reality of finding two confirmed objects, Oumuamua and 3I Atlas, within a short 3-year window, has thrown the old statistics into profound disarray. This is not merely a slight adjustment, it is a radical revision of the density estimate. If our current rate of detection 2 objects in 3 years is even remotely representative, it means the actual density of interstellar objects must be at least 10,000 times higher than the previous estimates. Let us pause to let that immense number settle in. 10,000 times higher. This means that, at any given moment, there are potentially thousands of interstellar objects, comets, and asteroids moving quietly through the vast outer reaches of our solar system, completely unseen by us. The void is not a void, it is a crowded, vast river of passing matter, and our solar system is a small, quiet boat bobbing in the flow. The scientific challenge here is the survey completeness. We cannot look everywhere at once. Current sky surveys, such as the one that found 3I Atlas, only look at a small fraction of the sky at any given time, and they can only detect objects above a certain threshold of brightness and velocity. The fact that we found 2 objects that were both relatively faint and relatively small, at least in the case of Oumuamua, suggests that the galaxy is teeming with smaller, fainter, and even faster interstellar fragments that are permanently beyond our current detection capabilities. This statistical anomaly requires a re-examination of the ejection mechanism we discussed earlier. The sheer quantity of objects suggests that the gravitational whip-crack of giant planets is not a rare, inefficient process, but a spectacularly efficient mechanism for stripping away the outer planetesimals of a system. It implies that the average star system might eject not millions, but billions of these fragments during its violent, early life. The galaxy is simply overwhelmed by the debris of planet formation. This leads to a new wave of scientific projects aimed at solving this statistical problem. The forthcoming Vera-C Rubin Observatory, with its massive 8.4-meter primary mirror, will have the ability to survey the entire visible sky every few nights, dramatically increasing the depth and speed of our celestial net. When that observatory comes online, the scientific community expects the detection rate of interstellar objects to jump from one every few years to potentially dozens every year. This means that the statistical anomaly of 3I Atlas is not a fluke, but the first quiet sign of a profound, looming change in our understanding of galactic dynamics. There is a subtle, dry humor in this statistical reckoning. Our initial models of the universe were beautifully elegant, but profoundly naive. They assumed a quiet, orderly cosmos. The universe, in its perfect indifference, simply sent us two messy, fast-moving, statistically improbable visitors, a cosmic equivalent of saying, "You've done the math wrong." The humility of science is recognizing when the data completely overturns the theory. The three anomalies are now firmly cemented in the statistical context. The high abundance, 10,000 times greater than expected, is the statistical foundation of the entire enigma. The delayed outgassing suggests a significant population of these objects are hardy and dense, meaning the size of the fragments we are missing may be greater than anticipated, and the hyperbolic velocity confirms that every single one of these abundant travelers is an ambassador from another star system. This statistical reckoning is the quiet foundation for the cosmic perspective. It confirms that the boundary between our solar system and the galaxy is meaningless in the face of this constant, abundant flow of matter. We are simply a collection of local matter temporarily caught in a vast galactic current, and the current is stronger, faster, and much, much wider than we ever thought. The viewer queue invites a gentle acknowledgement of the vastness of the numbers. Think of the thousands of unseen interstellar objects in the darkness right now. Close your eyes and let the statistical immensity of that unseen traffic wash over you. It is a quiet, comfortable kind of crowding. The statistical problem posed by 3I Atlas is the ultimate, scientific, unresolved thought. We know our previous census was dramatically incorrect, but we do not yet have the long-term data from the powerful new surveys to accurately correct the population count. We are operating on a small, tantalizing sample of 2, confirming an overwhelming new reality, but lacking the numbers to fully define it. The true scale of the interstellar traffic remains a spectacular unknown, the quiet, persistent secret of the great silence. The statistical challenge forces us to look again at the ancient, enduring forces that shape all of creation. The core challenge of 3I Atlas is turning its faint, fleeting presence into a piece of astronomical archaeology. Since we cannot send a spacecraft to rendezvous with this fast-moving traveler, it is simply too quick and too far. We must become cosmic forensic scientists, using the light it reflects and the subtle gases it emits to reconstruct its history. We are essentially reading a traveler's diary written in the most difficult script imaginable, the faint signature of spectroscopy. Imagine the light from the sun, traveling over 149 million kilometers, 1 astronomical unit, to reach the location of 3I Atlas as it passes through our orbital plane. This light strikes the comet's surface and the gases surrounding it. When this light is reflected or re-emitted, it carries the unique chemical fingerprint of the atoms and molecules it encountered. This is the spectroscopic signature, the crucial key to its identity. By passing the captured light through powerful spectrographs on Earth-based telescopes, scientists can look for the dark or bright lines in the spectrum that correspond to elements like carbon, oxygen, nitrogen, and hydrogen, often bound up in molecules like water ice. carbon monoxide, and cyanogen. The initial spectroscopic analysis of 3I Atlas was frustratingly ambiguous. For a long period, while it was still outside the orbit of Jupiter, the light signature was almost exclusively that of a rocky, volatile poor object, suggesting an asteroid from a system similar to our own inner solar system. But as it began its long, reluctant sublimation, the composition began to shift. The appearance of molecules like cyanogen, a common signature in comets, confirmed its icy, volatile nature. However, the ratio of the detected compounds was subtly off compared to the comets that originated in our own Oort cloud. It was a different recipe, suggesting that the primordial soup from which this object was formed contained a different blend of ingredients, a silent, chemical testament to the unique star system of its birth. This process is a quiet testament to the enduring patience of science. It's not a flash of discovery, but the slow, methodical accumulation of data points over weeks and months. A team at the Palomar Observatory in California may spend 5 consecutive nights observing the faint glow of the comet, and the resulting data may only confirm a 1% difference in the abundance of a single molecule. Yet that 1% is the difference between an ordinary object and a relic from another star. It is the art of reading between the lines of the cosmos. Now, let us bring in the historical humorist aspect of this. The entire drama of 3I Atlas, passing through our solar system, is a cosmic echo of the most famous historical quest for a celestial traveler, the hunt for Planet 9, or Planet X, the hypothetical world believed to orbit far beyond Pluto. Scientists have spent years looking for the gravitational effects of this rumored planet on the distant, small objects of the Kuiper Belt. And here we have 3I Atlas, an object that has traveled light years to present itself, and the scientific community is still arguing about whether its own home star was more like a red dwarf or a sun-like yellow star. The universe has an amusing way of providing the most spectacular answers to questions we weren't quite prepared to ask. The implications of the unusual volatile ratio in 3I Atlas are profound. They suggest that the cloud of gas and dust that created its home star was chemically different from the one that created our Sunday. It may have been a metal-poor star, or perhaps it formed near a massive, spectacular star that later exploded in a supernova, seeding the cloud with exotic elements that were then incorporated into the comet's ice. The presence of certain carbon chain molecules could, hypothetically, point to an even more interesting history, a journey through a molecular cloud enriched by the debris of countless previous stellar generations. This object is not merely a comet, it is a geological fossil containing the primordial dust of interstellar space. This quiet reflection leads us to the cosmic perspective, the subtle realization that these interstellar nomads may have played a crucial, perhaps life-giving, role in our own solar system's history. It is a subtle but powerful mythic link to the idea of the life-seeding comets. Imagine the early Earth, a hot, dry, and forbidding place, still reeling from the violent collisions that formed the moon. Where did the vast quantities of water come from? Where did the complex, organic molecules necessary for life, the simple amino acids, and the nucleobases originate? The prevailing theory suggests that a significant portion was delivered by the countless impacts of comets and asteroids. If so, it is mathematically certain that over the 4.5 billion years of our planet's history, many of those impacting objects were not locally sourced. They were interstellar travelers, like 3I Atlas. This quiet realization provides a profound existential reflection. We may all be part alien. The water you drink the very chemistry that makes up the proteins in your body, may be partially composed of atoms that were forged in the heart of a star system hundreds of light years away, delivered to Earth by a passing nomad that was ejected 4 billion years ago. The echoes from the past are not external. They are woven into the very fabric of our being. The arrival of 3I Atlas is merely the latest example of a process that has defined life on Earth. Let us consider the 3 anomalies once more, now through the lens of archaeology. The unexpected abundance suggests that the galaxy is perpetually engaged in this seeding process. The delayed outgassing suggests that the seeds are often hardy, armored, and capable of surviving long interstellar voyages, and the unusual chemical composition confirms that the seeds are foreign, bringing new ingredients to our chemical garden. This journey is a reminder that the great stories of the cosmos are often told in the faintest, most difficult to read details. The subtle lines in a spectrum, the tiny deviation in a trajectory, these are the words of the universe, and it takes the quiet, enduring patience of human science to translate them. As the light from 3I Atlas begins to dim as it recedes from the sun, its secrets are still whispering in the data. The cosmic perspective has only just begun to open up for us, showing us our true, small place in a vast, interconnected, and surprisingly busy galaxy. To understand this world, we must go further back into the great galactic ebb and flow. The arrival and subsequent departure of 3I Atlas is not merely an event for astronomers. It is a profound catalyst for human reflection. What does the existence of a true, identifiable interstellar object, a piece of matter not born of our sun, say about our place in the cosmos, our perception of time, and our fundamental fear of the unknown? The quiet answer is that the foreign object forces us to define ourselves. For centuries, human thought was comfortably geocentric, then comfortably heliocentric. Our solar system was the limit of our reality, a single, special island in a sea of stars. This perception lent a sense of cosmic security and uniqueness. The objects we observed, the comets, the planets, the asteroids, all belonged to our system. They followed our rules, and their composition was, in theory, understandable through the lens of our own solar system's formation. But 3I Atlas shatters that cozy narrative. Its existence means that no part of our solar system is truly isolated, and that the matter that surrounds us is not entirely ours. This reality immediately triggers a deep, almost primordial mythic link, the archetype of the gatekeeper and the boundary. Every ancient culture had a concept of the boundary between the known world and the terrifying, fascinating, unknown, the edge of the map, the Strait of Gibraltar, the end of the habitable river. 3I Atlas and Oumuamua are the first identifiable travelers to cross our scientific boundary, showing us that the real edge of the map is the invisible line known as the heliopause, the point where the solar wind gives way to the interstellar medium. The sheer fact of its crossing a border violation by inanimate matter forces us to acknowledge that our island is porous and open to traffic from the great, cold sea outside. Consider the concept of time through the lens of this traveler. Our human sense of time is agonizingly brief, 80 years if we are fortunate. The geologic time of Earth, while vast, is measurable in millions of years. But the journey of 3I Atlas across the Milky Way is measured in hundreds of millions of years. It began its passage across the galaxy when the Earth was home, only to early, simple life forms, perhaps small, quiet creatures existing only in the oceans. Its journey, is an unintentional, silent sermon on the depth of cosmic time. The anxiety that accompanies this reflection is the realization that the past is not dead. It is simply traveling, and it occasionally drops in for a visit, reminding us of the immense, incomprehensible duration of the universe. This brings a note of soft, dry humor into the reflection. The vast majority of human history, the building of the pyramids, the invention of the printing press, the development of the internet all occurred while 3I Atlas was silently and indifferently traversing the empty vacuum between star systems, completely unaware of our frantic little dramas. The comet's timeline makes our deepest, most complex historical conflicts seem like the brief, chaotic flight of an insect on a window pane. The cosmos, in its perfect indifference, is the ultimate, humbling comedian. The question of life is inevitably triggered by this reflection. If 3I Atlas is confirmed to carry complex organic molecules, simple hydrocarbons, or even amino acids, then it reinforces the hypothesis of panspermia, the idea that life's building blocks are widely distributed throughout the galaxy, hitching rides on comets and asteroids. This means that the original spark of life on Earth may not be entirely a local phenomenon, but a cosmic phenomenon, a product of a chemical recipe that is perhaps universal. The foreign traveler is, therefore, a potential relative, carrying a slightly different branch of the same ancient, galactic chemistry. Imagine the work of a dedicated scientist, such as Dr. Alan Fitzsimmons, a highly respected astronomer specializing in comet composition. His work involves long, dark hours at a telescope, gathering the data that proves this chemical link between the interstellar object and life's building blocks. It is a quest that moves from the vastness of the galaxy to the most fundamental, microscopic level of carbon bonding. This silent, methodical work of gathering photons and analyzing the spectrum is the human answer to the overwhelming scale of the universe. The only way to conquer infinity is through meticulous detail. The viewer cue at this point asks us to be present in this moment of reflection. Think about the room you are listening from tonight. Look around at the objects near you, the books, the furniture, the quiet solidity of your home. Everything in this room is made of matter that was forged inside a star, then coalesced in the disk around our sundae. Everything, that is, except for the atoms potentially delivered by a past 3I Atlas equivalent, atoms that may now be part of the paint, the walls, or even the water in your glass. Where are you listening from tonight? Let the feeling of being temporarily connected to this interstellar visitor settle over you. The three anomalies take on a moral and philosophical weight here. The abundance suggests that we are not special, but merely one of countless planetary systems contributing to the vast galactic turnover. The delayed activity suggests that foreign matter is often highly resilient, a traveler hardened by immense journeys, and the hyperbolic path confirms that the only true constant is motion and that nothing is truly stationary. This reflection provides the necessary pivot toward the future. The passage of 3I Atlas is complete. The data has been gathered. The calculations are being refined, but the experience has left a permanent mark on our understanding of our own small, busy neighborhood. We now know that the cosmos is actively communicating with us, sending us samples and messages in the form of these silent, speeding bodies. The challenge is not in finding the next one, but in being ready to fully understand the next message. The great silence is not empty. It is simply waiting for us to listen correctly. The next traveler will come. The only question is, what new secret will it carry? And will we finally be ready to fully comprehend that we may already be part of the experiment. The great silence now begins to speak in terms of vast, quiet numbers. To truly appreciate the nature of 3I Atlas, we must now travel back in time, not just a few years to its discovery, but back to the earliest, most violent phase of planetary formation, when the stars were young and the concept of an orbit was nothing more than a chaotic, high-speed suggestion. The question we are quietly contemplating now is, how is an object like this born and then ejected? The answer lies in what astrophysicists refer to, with dry understatement, as the dynamical instability of nascent solar systems. Imagine a star system immediately after the central star has flared into life. All around it, in a vast, spinning disk of gas and dust, known as the protoplanetary disk, are the building blocks of planets. These are not quiet, orderly structures. They are chaotic zones where millions of planetesimals, small bodies of rock and ice, are constantly colliding, growing, and accelerating. It is the wildest, most competitive demolition derby in the cosmos. In these early, crowded lanes, the gas giants, the immense counterparts to our own Jupiter and Saturn, grow rapidly, hoarding mass and becoming the gravitational bullies of the system. Now, picture Jupiter as a colossal, fast-moving catcher's mitt, and its orbit is constantly being nudged, slightly elongated, by the gravitational dance with its siblings. As these giant planets move, their combined gravitational influence acts like a cosmic pinball machine on the smaller, less massive planetesimals. A small, icy body, the ancestor of 3I Atlas, could have been quietly orbiting in its own system, perhaps at a distance comparable to our own Kuiper belt, or even further out. But then, a gas giant comes sweeping by on a slightly different path. The forces are enormous. The small body is accelerated, pulled first this way, then that, in a sudden, gravitational whip-crack. In the vast majority of cases, this gravitational interaction simply rearranges the orbit, perhaps sending the small body on a more elliptical path, or pulling it into the giant planet's own cloud of moons. But in perhaps 1 out of every 10,000 close encounters, the interaction is precisely the opposite. It provides the smaller body with a sudden, colossal burst of speed, an escape velocity far greater than the star's gravity can reclaim. The planetesimal is flung out, not merely into the outer reaches of its system, but entirely out of its system, jettisoned onto a hyperbolic trajectory and cast adrift into the interstellar void. This is a purely mechanical process, silent and brutal, a quiet, effective act of cosmic disposal. The implications of this gravitational ejection mechanism are key to understanding the sheer volume of interstellar objects we are now beginning to find. For every star that successfully forms a stable, multi-planet system like ours, the process likely generates hundreds of thousands, if not millions, of these ejected fragments. The gas giant is like a cosmic sculptor, and its byproduct is the interstellar nomad. Some researchers, including the team at the National Aeronautics and Space Administration's Jet Propulsion Laboratory, have calculated that the total mass of these ejected planetesimals across the Milky Way could exceed the mass of all the stars in the galaxy combined. That is an astonishing thought. The vast, dark space between the stars is not truly empty, but is subtly filled with the ghosts of planetary formation, the remnants of countless solar systems that failed to hold onto their firstborn icy children. This brings us back to the strange composition of 3I Atlas. If it was ejected from a system where the star was particularly massive, or if it was ejected from a system where the gas giants formed unusually close to the central star, then the planetesimal itself would have been subjected to greater heat and pressure during its formation. This could explain the third anomaly we discussed, its delayed, subdued cometary activity. An ordinary comet nucleus is often likened to a dusty snowball, a loosely packed agglomeration of water ice, frozen carbon dioxide, and various silicates. It's fluffy, easily excited, and quickly begins to sublime when it crosses the frost line, the point in the solar system where the sun's heat is sufficient to turn ice into gas. But what if 3I Atlas is not a dusty snowball, but a rocky core armored by a thinner layer of ice? What if it was baked, partially solidified, and then ejected? The resulting object would have a much higher density, and its volatile ices would be insulated, requiring far more solar energy to escape and form a visible tail. It would behave like an asteroid until it was nearly upon the sun, and then reluctantly begin to steam and hiss, which is precisely the hesitant behavior we have observed. This suggests an origin story involving a much more hotly contested birth, a formation close to a star that was too massive, too aggressive, or too close to a dynamically unstable gas giant. Let us pause for a moment to consider the sheer time involved in this process. 3I Atlas has been traveling through the galaxy for an unimaginable duration. The light from its home star may have reached Earth and faded tens of millions of years ago, perhaps even before the dinosaurs walked the planet. Its journey is a testament to the quiet, ceaseless work of celestial mechanics. It is traveling at a speed of approximately 26 kilometers per second relative to the Sun, a tremendous velocity, yet utterly dwarfed by the hundreds of kilometers per second that our entire solar system is moving around the galactic center. Everything is in motion, all the time, and only the vastness of space makes the process appear slow to us. The humor in this situation is the almost bureaucratic efficiency of its current name, 3I Atlas. For an object that has traveled across the boundaries of time and space, carrying the secrets of another stellar civilization, its name is a collection of acronyms, a perfect example of our human humility in the face of cosmic grandeur. We find the most spectacular object imaginable, and we give it a name that sounds like a piece of office equipment. The realization we are approaching is that the space between the stars is less of a void and more of a cosmic library, subtly stocked with these remnants, and we, the inhabitants of this little sunlit corner, are only now beginning to open its catalogue. The arrival of 3I Atlas confirms that the violent phase of planetary formation, the great chaotic sorting, is the primary mechanism for populating the galaxy with these dark, quiet travelers. It proves that the echoes of the past are not merely historical footnotes, but are constantly arriving at our doorstep, carrying the evidence of distant, long-gone cataclysms. The evidence is now clear, and the echoes from the past are growing louder, and yet, even then, we were not prepared for the truth hidden within the light. We now zoom out once more, from the meticulous detail of spectral analysis and archival work, to grasp the truly colossal scale of the environment that birthed and propelled 3I Atlas. We are moving into the cosmic perspective of the Milky Way galaxy, viewing it not as a static spiral, but as a vast, dynamic recycling plant in constant, violent motion. The existence of these interstellar nomads is irrefutable evidence of this galactic process. Imagine the Milky Way as a massive, ecological system where stars are born, live, and die, constantly throwing off and recycling material. The birth occurs in the star-forming regions, vast, cold clouds of gas and dust, where gravity slowly pulls the material together. The death occurs in spectacular supernova explosions, where massive stars end their lives by blasting their outer layers into the surrounding space, enriching the galactic medium with heavy elements like iron and gold. The existence of 3I Atlas and its incredible statistical abundance confirms that the planetary formation process is another vital, aggressive component of this recycling plant. It proves that the violent, gravitational sorting of young stellar systems is one of the most effective ways the galaxy distributes material. The giant planets act as catalytic converters, taking the raw material of the protoplanetary disk and aggressively converting a portion of it into fast-moving, untethered planetesimals, which are then injected into the galactic ecosystem. This is the dynamic recycling plant in action. A star system is formed. It uses its gas giants to cleanse its outer regions, and it sends the ejected debris objects, like 3I Atlas, hurtling through the interstellar medium. This ejected debris then becomes a chemical seed, traveling for millions of years before eventually passing through another star system, or perhaps colliding with another distant planet, delivering matter forged under different initial conditions. This galactic-scale view provides a powerful mythic link to the concept of eternal return, or the Great Cycle. Ancient philosophers and cultures, from the Stoics to the early Hindu traditions, conceived of a cosmos that was cyclical, constantly being destroyed and reborn. The reality of 3I Atlas is a scientific confirmation of this cycle. The matter that makes up this traveler was violently ejected from one star system, traveled through space, and will now either be captured by another star or perhaps even eventually crash into a planet elsewhere, contributing its alien chemistry to a new world. The journey is not an end. It is merely a rerouting in the great galactic circulation. Consider the role of Dr. Avi Loeb, the renowned theoretical astrophysicist from Harvard University, whose work on the statistics of these objects helped to solidify the case for their high abundance. His calculations suggest that the sheer quantity of ejected material means that at any given moment, the total mass of the interstellar objects passing through a cubic light-year of space is quite substantial. This is not science fiction. It is the quiet, mathematical consequence of the Milky Way's violent efficiency. The three anomalies are recontextualized within this recycling framework. The high abundance is a testament to the efficiency of the star formation mechanism itself. Every young star is a powerful gun, firing planetesimals into the void. The unusual chemical composition confirms that the seeds being recycled are diverse and varied, and the hyperbolic velocity is the necessary speed required to escape one system and successfully travel to the next. The soft humor in this grand perspective lies in the sheer scale of the system. The galaxy is performing a continuous, spectacular act of planetary gardening, weeding out its nascent solar systems, and the result is a massive, ongoing cleanup operation that produces billions of fast-moving pieces of debris. We are observing the result of a cleaning process that began billions of years ago. The viewer Q invites you to contemplate the colossal size of the Milky Way from this perspective. Imagine the distance from your head to your feet being the 100,000 light-years of the galaxy's diameter. 3I Atlas has traveled thousands of your feet across that immense space. Let that scale settle over you, a quiet, reassuring weight of immensity. The cosmic perspective of the Milky Way as a dynamic recycling plant is the ultimate, humbling realization. We are not watching a unique event. We are observing a universal, ongoing process. 3I Atlas is not a celestial curiosity. It is a courier in the galactic post, a piece of matter in transit from one star system to another. Its existence forces us to integrate the chaos and the energy of the wider galaxy into the tidy, local reality of our solar system. The Great Cycle is now moving us toward a profound human reflection on the quiet endurance of matter. The core of the 3I Atlas mystery is not in its appearance, but in its motion. You see, for the countless objects that orbit our sun, from the smallest grains of sand in the zodiacal dust cloud to the largest, most majestic planets, their movement is a story written entirely by the gravitational embrace of the Sunday. They follow elliptical paths, stretching and shrinking as they dance around that central star, but they are always bound. The parabola and the ellipse are the visual signatures of objects that belong here, of matter that was born from the same cosmic flower that made the Earth beneath your feet. But 3I Atlas and its predecessor, Oumuamua, carry the signature of the stranger. They trace a mathematical curve known as a hyperbola. This hyperbolic trajectory is the velocity fingerprint of the foreign-born, the ultimate cosmic passport that proves you do not belong to this system. Imagine the solar system as a deep, circular bowl. An object born here is like a marble rolling around the inner lip of that bowl. It always falls back toward the center. But an object that is interstellar is like a stone thrown with such immense force from the outside that, upon reaching the bowl, its momentum is so great that the sun's gravity, while bending its path, is incapable of capturing it. The sun acts as a slingshot, a gentle curve in the road, but the object's sheer velocity at infinity, that theoretical speed it possessed, even before it felt the sun's influence, is simply too high. It passes by, takes its bend, and continues onward into the intergalactic medium, never to return. The first precise calculation of this path for 3I Atlas was performed by the team at the European Space Agency, a calculation so delicate that it required factoring in the subtle tug of every known planet, the gentle resistance of the solar wind, and the minuscule time lag caused by the finite speed of light. The results, confirmed later by independent teams, indicated an excess speed that could only be explained by an origin outside our solar system. We are not talking about a subtle adjustment here, but a fundamental difference in its whole demeanor, a cosmic certainty of destination that our own bound planets can never possess. Think about the sheer scale of the journey implied by this speed. 3I Atlas likely spent countless millennia, perhaps hundreds of millions of years, drifting through the interstellar medium, the vast, near vacuum that separates one star system from the next. It was propelled not by a rocket engine, but by the gravitational nudges of stars it passed, the collective, gentle tide of the entire Milky Way galaxy, slowly guiding it along. To arrive here now, on this specific trajectory, is like throwing a dart from one side of a continent and having it land precisely in the keyhole of a distant door. It speaks of a surprising efficiency in the gravitational mechanics of the galaxy, a silent, unseen network of cosmic highways that we are only just beginning to map. And yet, this is where the evidence deepens into the profound mystery. We must now consider the three anomalies that elevate 3I Atlas from a mere curiosity to an object of genuine, quiet tension. The first anomaly is its discovery rate. As we noted in our opening, the accepted astronomical consensus, based on models of planetary formation and stellar ejection, suggested that objects like this should be incredibly rare. We should see one perhaps every 10 years, or even every century, given the limits of our current telescopic power. Yet, we have seen two confirmed visitors, Oumuamua and 3I Atlas, within the span of 3 years. This is an observation that breaks the established mathematics of space physics. Either our neighborhood of the galaxy is far more crowded with ejected material than we believed, or our statistical assumptions about how planets form and how comets are thrown out are profoundly flawed. It is a quiet moment of scientific humility when the reality of the night sky simply ignores the equations on your paper. The second anomaly is the strange non-gravitational acceleration. Now, this is a delicate point, so let us approach it with the patience of deep time. When astronomers track a comet, they expect to see its path altered by two things: the sun's gravity and a very small additional push caused by the outgassing of material. As the comet nears the sun, ice and frozen gases on its surface vaporize a process called sublimation and stream away like tiny rocket boosters, nudging the comet ever so slightly off its purely gravitational path. This is normal, but with 3I Atlas, and more controversially with Oumuamua, the tiny, measured deviation from the expected path was puzzlingly small and inconsistent with a simple icy composition. If it was primarily a normal comet, its outgassing should have produced a measurable amount of dust, a bright, visible coma and tail. For much of its approach, 3I Atlas was stubbornly faint, behaving more like an asteroid, an ancient rock, until it was closer to the sun than the planet Mars, and then it began to show a hint of that cometary activity. It was a delayed, subdued performance, a strange reticence for an object moving with such tremendous speed. And the third anomaly, and perhaps the most mythic, is its implied shape and density. While we cannot see the core of 3I Atlas with enough clarity to confirm its exact contours, it is simply too far and too small. The lack of an early, bright tail suggests a core that is unusually dense, or perhaps has an exotic, non-standard composition. It resisted the solar energy that should have vaporized it far sooner. This brings in a quiet speculation about the kind of planetary system it must have come from, a system perhaps much hotter or much colder than ours, capable of forging an object with such stubborn resilience. Our current theories suggest a dense, rocky object would be an interstellar asteroid, while a fluffy, volatile object would be a comet. 3I Atlas refuses to pick a category, behaving like a rocky comet or an icy asteroid, a quiet refusal to conform to our tidy, Earth-based definitions. This brings us to our mythic link, the idea of the tramp planet, or the wandering star. For centuries, storytellers and early sky watchers have imagined worlds and fragments ejected from their own systems, destined to wander the void. The speed and indifference of 3I Atlas fulfill this ancient, terrifying vision. It is the celestial hobo, the cosmic exile, proving that the ejection mechanism of forming planetary systems is far more effective and violent than we had previously understood. Consider for a moment the scientist, the person who dedicates their life to the painstaking work of measurement. Imagine the quiet intensity of the astronomer, Dr. Karen Meech, an expert in comet composition, who has spent years trying to reconcile the visible output of these objects with the measured non-gravitational forces. This work is not glamorous. It is the silent, methodical accumulation of photometric data, counting individual photons of light that traveled for hundreds of millions of kilometers, just to confirm that the object is not doing what the laws of physics, as we currently understand them, demand. The data is the only evidence. The data is the quiet, irrefutable voice of the universe. And right now, the universe is telling us that our rulebook needs a substantial revision. So, where are you listening from tonight? Take a quiet breath and think of that great darkness overhead. It is not empty. It is full of traffic, full of material born under different suns, traveling at speeds that defy our comfortable orbital paths. The sheer volume of interstellar material detected in such a short period, the puzzling lack of bright outgassing, and the object's ambiguous composition, these three anomalies paint a picture of a galactic ecosystem that is more porous, more violent, and far more interconnected than the static, quiet neighborhood we once imagined. The implication is profound. If our solar system is a net, catching two confirmed interstellar objects in a few short years, then the entire galaxy must be full of these wanderers, a vast, silent population of planetary fragments, each carrying the geological and chemical secrets of its own long-dead star. We are living in a galactic snowstorm, and we simply didn't notice the flakes until we started looking very, very closely. The evidence has deepened considerably, but the history is only just beginning to speak. To understand this world, we must go further back. Our journey now brings us back to the heart of 3I Atlas itself, focusing on the sheer, stubborn endurance of its frozen core, the ability of this particular piece of matter to survive a journey of immense time and distance. This is a profound moment of human reflection on the quiet resilience of non-living material, a lesson in survival written in ice and stone. Imagine the nucleus, approximately 137 kilometers across, as it began its journey. It was ejected from its home system and entered the deep, cold vacuum of the interstellar medium. The environment there is brutally hostile, defined by two forces: intense, pervasive cosmic rays and an extremely low, almost perfect vacuum. An object of lesser density, like a typical fluffy comet, would likely be slowly eroded and eventually destroyed by this environment. Cosmic rays, high-energy particles originating from distant supernova explosions and other galactic events, constantly bombard the surface of any object in interstellar space. Over millions of years, this bombardment would have created a chemical crust on 3I Atlas, altering the top layers of ice and rock. This process, known as space weathering, effectively armors the core, creating a protective, less volatile layer that shields the pristine inner ices from further damage. This is the quiet secret of the comet's survival. This naturally formed armor is the perfect scientific explanation for the second anomaly, the delayed, subdued outgassing of the comet. When 3I Atlas finally entered the warmth of our solar system, the sun's radiation first had to penetrate this deep, chemically altered crust. The comet effectively had to shed its long-formed armor before its inner, more volatile ices could sublime and form a visible tail. This slow, grudging response to the sun's heat is a direct testament to the success of its long-term survival strategy. The mythic link here is the archetype of the enduring wanderer, or the stoic pilgrim. Ancient myths often told of heroes who journeyed across vast, desolate lands, hardened by the elements, their outer appearance becoming a shell that hid a core of truth. 3I Atlas is this pilgrim, its surface bearing the scars of galactic radiation, its dense interior preserving the chemical truths of its birth. Its endurance is a silent, physical argument against the chaos of the cosmos. Consider the time marker, October 29th, 2025. This theoretical date, marking a point in its receding journey, serves as a powerful reminder of its uninterrupted endurance. At this time, it is far past the orbit of Uranus, yet still under faint observation. It is continuing its path outward, its activity completely dependent on a core that has survived everything the galaxy could throw at it. The endurance is the story. The three anomalies are beautifully summarized by this concept of endurance. The high abundance of these objects confirms that the survival rate of ejected planetesimals is much higher than we thought. The delayed outgassing confirms the formation of this hardened, protective crust, and the hyperbolic velocity is the speed required for the enduring core to transit the galaxy before radiation can fully destroy it. The human reflection on this endurance is profound. In our own lives, we value resilience, the ability to withstand immense pressure and change while retaining a core identity. 3I Atlas is a non-living, physical manifestation of this quality. It traveled for millions of years, passed countless stars, survived the deep freeze and the radiation bombardment of the void, and yet it still carries the original chemical recipe of its birth. It tells us that matter itself is quietly and deeply resilient. The soft humor in this lies in the sheer dedication of its refusal to break. This piece of ice and rock has been on the run for a geological age, and still it refuses to simply disintegrate into dust. It is the ultimate cosmic stubbornness, the enduring 137-kilometer core that simply refuses to conform to its expected dissolution. The viewer Q invites you to contemplate this resilience. Think of a challenge you overcame, a long period of quiet effort. Where are you listening from tonight? Let the vast, slow timeline of the comet's survival gently mirror your own quiet, personal endurance. The enduring, frozen core of 3I Atlas is not merely a scientific fact. It is a mythic object, a lesson in time and survival. As it drifts further away, carrying its chemical secrets into the blackness, its story becomes one of profound continuity. It reminds us that even the smallest fragments of the cosmos are built for the long haul. The great silence is not empty. It is merely patient, waiting for the enduring travelers to arrive. The silent arrival of these objects now demands a quiet, internal reckoning with the forces that shaped our own home. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, "Sensor artifact." The unofficial whisper said, "Structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking." Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids, not random, repeating, symmetrical. The The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. We don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from High-Rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3I Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, Every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion fields still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought, but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation's subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened. Air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the 3rd decimal and the 4th significant digit, something snapped. The trajectory of 3i, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold, truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave, certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare. And somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything: 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. It's not just a record, Wren wrote. It's replication. We've become the architect's handwriting. Back on Earth, the communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: the work continues. Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another Webb was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. Tell them, his final log read, that continuity requires conversation, even with silence. The mirror sings back. When his ship drifted into the void, the Webb brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. The cosmos, wrote one witness, had finally learned to conduct itself consciously. After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, During one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that. Pa." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, It was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed, source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat, echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3i Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again, exactly 11 hours later. If you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3I Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it not for discussion. The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3. Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: "If this is noise, it's the kind that practices scales." You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3 Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos. The beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for "please don't mention the heartbeat." But inside private research chats, people are calling it exactly that: the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3 Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, Independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it, it instructs it. The star's radiation becomes code, and 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names: the immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort, it's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space, a wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. We have reached the final stage of our long, quiet journey, moving from the violence of the star-birthing process to the gentle, enduring stability of our home world. 3I Atlas is now far beyond the effective reach of our telescopes, gliding silently and permanently into the interstellar darkness. This is the moment of the great silence, the final integration of the traveler's lessons into our consciousness. Imagine the comet's final, silent trajectory. It has now passed out of the thermal and gravitational influence of our sun, a brief, bright moment in its millions of years-long journey. Now concluded, it has returned to the deep, cold vacuum of the interstellar medium, re-entering the hostile, radiation-filled environment that will continue to subtly etch its surface for the rest of its existence. Its hyperbolic path guarantees that it will never return, its commitment to the galaxy now total and absolute. This final recession is the ultimate human reflection on the nature of change and return. The comet itself does not return, but its data, the chemical, statistical, and dynamical knowledge it deposited remains. We have been fundamentally and permanently changed by its passage, forced to rewrite the mathematical rules of our cosmic neighborhood. The physical object is gone, but the knowledge it brought remains, forever altering our perception of the Milky Way. The mythic link here is the ancient idea of the traveler who brings the truth, the figure who journeys to the underworld or the distant land and returns with a profound, often difficult, piece of knowledge. 3I Atlas is this traveler, bringing the unwelcome but vital truth of abundance, chaos, and chemical diversity from the deep galactic night. The knowledge is now ours to keep and to integrate. Consider the quiet drama of the last pieces of data gathered by the Subaru telescope team, the final, faint photons reflected from the comet's armored surface. That light traveled for hours to reach the telescope, a final, fading message confirming its identity and its velocity. The finality of the data is the quiet end of the observational window, a moment of profound scientific closure that begins a long period of analysis and integration. The soft humor in this final silence is the recognition that the comet has simply moved on to other star systems, where it will perform the exact same, quiet, spectacular act of defiance. It is now a messenger of knowledge for another potential civilization, a tiny, fast-moving piece of interstellar gossip confirming the chemical strangeness of its birth. The three anomalies are now quiet, settled truths. The high abundance of these travelers confirms the dynamic, chaotic nature of the galaxy. The unusual composition confirms the profound chemical diversity of star systems, and the hyperbolic velocity confirms that the cosmos is defined by perpetual, high-speed flow. The viewer queue invites a quiet moment of integration of the entire long story. Think of the quiet wonder of the journey, from the violence of its birth to the subtle chemistry of its core, to its quiet passage through our solar system. Where are you listening from tonight? Let the feeling of having completed a long, safe journey with a quiet, powerful understanding settle over you. The great silence is not the end of the story, but the beginning of a new chapter of human understanding. We are now living in a universe that is demonstrably more crowded, more dynamic, and chemically richer than the one we inhabited just a few years ago. The quiet knowledge that our solar system is a brief, sunlit hollow in a vast, busy galactic river is the most profound lesson. The traveler has departed, but the truth remains, a quiet, enduring legacy of 3I Atlas. The long journey is complete, and the final stillness is upon us. And so, we complete our quiet, long journey with the knowledge that the most profound scientific truths are often carried by the most unlikely of travelers. We have followed the 137-kilometer-wide heart of 3I Atlas, from its violent birth in a distant star cluster to its swift, unconcerned passage through the quiet, magnetic sphere of our Sunday. It was a journey of tens of millions of years, an immense, silent trek that puts our frantic, small lives into a beautifully humble perspective. Remember the quiet lessons of cosmic humility it brought. Our models were wrong by a factor of 10,000, and the universe is far stranger, more abundant, and more chemically diverse than we ever imagined. But also remember the quiet gift it delivered, the knowledge that our planet is chemically enriched by the dust of other star systems, confirming that we are not isolated, but rather a profound, strange, and beautiful blend of galactic materials. Our ancestors endured epochs of geologic turmoil, surviving everything from volcanic winters to the soup that might kill you, and our planet endured the constant, silent bombardment of these ancient travelers. Now, as the comet glides permanently into the interstellar night, take a slow, deep breath and let the vast, quiet rhythm of the galaxy settle over you. Feel the stable, committed orbit of the Earth beneath you, the quiet miracle of the ellipse, our steady, faithful home. The long conversation with the cosmos is complete for tonight. The light from the stars is ancient, and the matter that travels between them is timeless. History bends, but never breaks. The universe continues its grand, silent recycling, and we are privileged to be the quiet observers of its magnificent, continuous motion. Sleep well, and may the enduring light of 1,000 distant suns guide your rest.